Hello, Mr. Fraser, and anyone looking at my YouTube. Today, we'll be talking about my bone model. Very cool, very nice, fun to play with. Okay, so before we get into the details about the model, you need to know that there's 3 forces that a bone needs to be able to withstand. So the first one is compression, where the ends of the bones would be compressed inwards, like that. The second one is distraction tension, which is where the bone ends would be pulled apart. And then the last one is torsion, so twist. Obviously my bone is made out of paper, so it's not really ideal for me to be doing these things, but your bone does a way better job at absorbing these stresses. So now moving on to the actual model. The long axis of the bone is called the diaphysis, which is a thick collar of compact bone. So on my bone, the diaphysis is made out of some cardstock paper, and I chose that because it is thick and it is able to keep its shape. So the diaphysis is covered by a glistening white double-layered membrane called the periosteum. The periosteum stimulates the continuous formation of new bone from the outside or external side of the bone. So you can find osteoblasts and osteoclasts in this structure, but I'll talk about those later. To represent the periosteum, I wrapped the diaphysis portion of the bone in cling wrap to reference its glowing characteristic. At the ends of each bone, there's epiphyses. So these are represented by my old roller skating toe stops. So the function of epiphyses are to absorb stress and cushion opposing bone ends during movement. I chose my toe stops to represent this part of the bone because, like the epiphyses, they have some shock absorbing qualities. So if we move on to the interior of the epiphyses, you find spongy bone. So it is represented here by orange pipe cleaners. Spongy bone allows the ends of the bone to compress whenever stress is applied to the bone. I just have a pipe cleaner represent the spongy bone because it's pretty soft and I feel like it would absorb some stress. So this is what the inside of my model looks like, and the first thing I'm going to talk about is the perforating ridges. So to connect the periosteum to the underlying bone, there are perforating ridges, which are represented by the ridges in the cling wrap because they look fairly similar to perforating ridges, in my opinion. The internal bone surfaces are covered with endosteum, which is represented by this non-slip mat. Here. There's the mat. So, the endosteum stimulates bone resorption inside the bone, and it's also another place where you'll find osteoblasts and osteoclasts. So the non-slip mat lining was chosen because when I was looking at models of the endosteum, it was pretty bumpy, so I felt that the irregular texture did a good job representing that aspect. So we're finally going to talk about osteoblasts and osteoclasts. So osteoblasts in my model are represented with rhinestones, and osteoblasts are bone-forming cells. And I chose rhinestones to represent this because they have a circular shape, and I felt that it reminded me of a cell, so I chose rhinestones. So opposite to an osteoblast, there's osteoclasts, and osteoclasts are bone-destroying cells. So I have one represented here with a purple pipe cleaner. So I chose this purple pipe cleaner, which I rolled up into a little pom-pom because of its circular shape, so it'd be like a cell. And then I feel like bone destroying is a pretty menacing thing to do, and purple is a menacing color, so that's why I chose purple. Now, if we're looking inside more, you'll find the medullary cavity, which is made out of yellow cardstock paper, which is fitting because the medullary cavity holds yellow bone marrow, which is represented with yellow pipe cleaners, which I obviously chose because they're yellow bone marrow, you know? So yellow bone marrow produces cartilage, fat, and bone, and it also stores fat cells, which are called adipocytes. And that is it. Just kidding. I know you thought I forgot about the osteon. So we know that the osteon is found inside compact bone. It's a structure found in compact bone. And I decided to be able to explain more and have a better model of the osteon. I would make my own little tiny osteon model. So osteons provide the bone with protection and strength, and in the core of each osteon there is the Haversian canal, so it's hollow inside. And this canal contains small blood vessels and nerve fibers that serve the needs of the osteon's cells. And in each osteon there are concentric layers called lamellae. So these layers are represented with this purple like rolled up paper because it resembled the layers, you know? And so these layers contain a mineral matrix and osteocytes connected with canaliculi. I'm sorry if I'm pronouncing that wrong. But canaliculi are hair-like canals that connect the lacunae to each other and to the central canal, which allows blood to be transported, things like that. So in my model, the canaliculi is represented with this like torn up cotton ball, because I felt like when you tore it up, you could kind of see like hair-like fibers, which represent the hair-like structure. And furthermore, lacunae are small spaces between the lamellae. So it'd be like these small spaces in between the rolls of paper. And yeah, that is all I gotta say about the bone and the bone model. So I hope you enjoyed. And these are my two models. Pretty cool, pretty fun. Okay, thank you, Mr. Fraser. Have a great day.